everybody, this is Miss Bufford, and this video is going to cover building block 5 from Unit 12 over solutions. And in this building block, we're going to be talking about solubility rules. Your learning goal for building block 5 is to be able to use the solubility rules to determine if a substance will dissolve in water. And so our solubility rules are a set of rules that allow us to determine if an ionic compound is going to be soluble in water or not. So will it dissolve in water, or will it either remain a solid or produce a solid product? And you'll see in the next building block, we're going to use the rules that we learn in this building block to be able to predict whether a new product will be formed in a double replacement reaction. And so here are the solubility rules. This chart is listed in the middle on the back of your periodic table from class. If you don't have that out, I would go ahead and pause the video and grab it. If you don't have a physical copy of it, you can find another copy in It's Learning. But if you take a look at these solubility rules, up at the top, you can notice that it's divided into two sections. The top section up here contains a list of ions that when these are in compounds, those compounds tend to be soluble in water. Most of the compounds that these ions are in are soluble in water, unless those compounds are in ions that are listed as exceptions. So you see where the little red oval popped up? Those list all the exceptions. And if you notice up here at the top, it's only the last 4 ions, so bromide, chloride, iodide, and sulfate, that have exceptions to their rules. And if they meet an exception, then they're no longer going to be soluble in water. If we take a look down at the bottom portion of this chart, this is a list of ions that tend to form compounds that are usually insoluble in water. So most of the compounds that these are found in are insoluble. They will not dissolve in water unless they meet one of these common exceptions. So there's a lot more exceptions down here on the bottom of this chart. And in the rest of this video, I'm just going to go through and do some examples for you guys so that you can get the hang of reading the solubility chart and applying those rules. So let's go ahead and do some practice. All right, so let's do some practice. And we're going to go through these compounds 1 through 12 and label them with either an S for soluble or an I for insoluble. Okay, and we're going to use our solubility rules to help us determine whether these compounds will be soluble or not, whether they'll dissolve in water or not. And so let's go ahead and quickly review this again. So before we said that all of the ions that are listed up here at the top of the chart, we always start off assuming that any compound that contains these ions is going to be soluble unless that compound meets one of these common exceptions, okay? And then down here at the bottom, we always start off assuming the compounds containing these ions down here are insoluble unless we meet one of these common exceptions here. All right, so let's go ahead. Actually, let me point out one more thing. So if we take a look at this list of ions, the entire chart, all but one of them has a negative charge. So we're looking for the negatively charged portion of these formulas over here. And if you're wondering to yourself, I don't really remember how to tell which one's positive and negative, then we're going to review that really quick. So when we write a chemical formula, we always list the positively charged portion first and then the negatively charged portion. And metals have a positive charge, and then the rest of that formula would be like, this is our chlorate polyatomic ion, that's going to have a negative charge. So we always want to identify what the negative part is so we can find it over here in this list. All right. So we've got sodium chlorate here. I'm looking for chlorate, so I'm going to come over to my solubility rules, and here's chlorate right here. And it says, so we start off assuming that's going to be a soluble compound, and there are no exceptions for that, so this is going to be soluble. All right, so now let's do silver bromide. So we know that silver is going to be our positive charge, And bromine is going to have to be our negative charge, so we're going to look for the bromide ion. So I'm going to come over here. I'm going to start at the top, work my way down. Oh, there's bromine right there, with the bromide ion. And it's in a compound with silver. Let's see its exceptions. Oh, silver is one of the exceptions. So initially, we start off thinking this compound is going to be soluble because this is up here at the top part of the chart. But since it's in a compound with silver, that's an exception. And so now that is an insoluble compound. Okay. Lead cyanide, number 3. Lead is our metal. That's going to have a positive charge, which means cyanide is our negatively charged polyatomic ion. And so let's go over here to our chart, and we're starting at the top and working our way down. And here's cyanide right here. And cyanide has no exceptions, so all compounds that contain cyanide are going to be soluble. All right? Lead chloride. So lead, again, that's our metal, so that's going to have a positive charge. Chlorine is going to be negatively charged. So let's take a look over here. We're looking for chloride ion. There it is right there. And it's in a compound with lead. Let's see if that is an exception. There's lead right there. That's actually lead 2. And since there are 2 chlorines attached to that lead, that means that is lead 2 in that compound. And that is going to be insoluble. We started off thinking chlorine was soluble, but then there's the exception to the rule, so now it's insoluble. All right, cobalt hydroxide. So cobalt is a metal, it's positively charged. Hydroxide is our negatively charged polyatomic ion. I'm going to start my way up at the top, and I'm going to work my way all the way down to the bottom. There's hydroxide right there. And if you have your periodic table out, which I definitely recommend that you should have that out while we're doing this, because we need to know, whether this metal is an alkali metal or not. And cobalt just happens to be a transition metal, so it's not an alkali metal. And so this compound doesn't meet any of the exceptions, which means it's going to be insoluble. Okay, because it's at the bottom, and we assume these are insoluble unless they meet an exception. Okay. The next compound, number 6, is aluminum phosphate. Aluminum's going to have our positive charge. That's our metal. Phosphate's going to have a negative charge. So we're going to come up here. We're going to work our way down looking for phosphate. And here's phosphate right here. And it's in a compound with aluminum. And it says that the only exceptions are the ammonium ion or an alkali earth metal cation, and aluminum is a group 3 metal, so that is going to be insoluble because it does not meet any of those exceptions. All right, and I'm just going to go ahead and put a 2 in here because this is supposed to be calcium dichromate. But we've got calcium as our positive charge, and then the dichromate ion as our negative charge. And so I'm going to come over here and start at the top and look for dichromate. And here is dichromate right here. And let's see, it's calcium. And calcium is an alkaline earth metal. It's not an alkali metal. So there are no exceptions met here, meaning this compound will be insoluble. Okay. Now let's look at number 8. Number 8 is kind of interesting because it has no metals in it, but it is an ionic compound because we've got the ammonium ion here and the hydroxide ion, ammonium hydroxide. And so we already talked about and pointed out the fact that ammonium is a positively charged ion and hydroxide is negatively charged. And so there are 2 rules that govern this compound, and they should both tell us the same thing. So let's go ahead and take a look at that. So ammonium right here has a rule for it, a solubility rule, and it says that we start off assuming that this is soluble and there are no exceptions, so this compound will be soluble in water. And let's just double check that with the rule for hydroxide, which is all the way down here. And it's on the bottom of the chart, so we start off assuming this is going to be an insoluble compound because most things that contain hydroxide groups or hydroxide ions are insoluble. But ammonium is one of the exceptions, and so that also tells us that this compound is soluble. Okay. Number 9 is magnesium sulfide. So magnesium is our metal, and the rest of that is our negative charge. And so we're going to start at the top and work our way down to the bottom. And here is our sulfide ion right here. And magnesium is an alkaline earth metal, and it is not an exception to the rule. So this is going to be insoluble. Okay, now let's talk about number 10, potassium sulfide. So again, we're looking at this sulfide ion down here, and potassium is an alkali metal. So the exception here that's being met is that we have an alkali metal cation. And so now this compound will be soluble because we started off thinking insoluble, but it met an exception, so now it's soluble. All right, and sodium nitrate. So let's find nitrate on here. Here it is right here, NO3. And there are no exceptions for that. So that is going to be a soluble compound. And then silver iodide. So let's take a look for iodide. There's our iodide ion. And let's take a look at the exceptions. Silver is not an exception here, so this is going to be a soluble compound as well. All right. If I went a little bit too fast, you're welcome to go ahead and rewind and just watch this last portion of the video. Again, if you'd like, if you have questions and you're not sure why we got the answers we got, you're welcome to contact me either during office hours between 10 and 11 a.m. Monday through Friday, or you can send me an email and I'll try to get back to you as soon as possible.